Oh.
Alright, 13. Add set 1 and set 2 together is the first thing you should do. So 4 minus 3i plus 5 plus 5i. So that should be relatively easy. You should get 9 plus 2i. Everybody cool with that? Now, so it's going to be k times 9 plus 2i is equal to 18. And we'll multiply this out and we get ti plus 2i. We good? We should get 9k plus 2ki equals 18 plus ti plus 2i. Everybody cool with that? 9k equals 18 and 2ki equals ti plus 2i. Exactly. 9k will therefore equal 18 and k therefore should equal 2. And then 2k, which is on the left, will equal the t plus 2 on the right. Okay? Then k is what, guys? K is 2. So 2 times 2?
4.
4. 4 equals t plus 2. So what's t?
2.
What plus 2 equals 4? 2. Let's keep going. 15. Find two real numbers k and t such that k times z plus t times z, the conjugate, is 2 z squared. So, first thing I'm going to need is the conjugate. What's the conjugate?
Z plus 3. Or 1 2.
1 plus 2i. Next thing I need is z squared. So what's z squared? 1 minus 2i multiplied by?
Minus 2.
Exactly. And what we should get here is 1 minus 2i minus another 2i. What's 2i minus 2i by minus 2i, Oscar?
Plus 4.
I squared, yeah. Which is otherwise known as?
Minus 4.
Yep. And 1 take away 4, Oscar?
Minus 3.
Minus 3 minus 4, right. We cool with that? Now, k times blank plus t times blank equals 2 times blank squared. Or, well, 2 times blank. Alright, what am I going to sub in here, guys?
1 minus 4.
In here is going to be 1 minus 2i. And in here is?
1 plus 2.
Yeah. And over here?
1 minus 2.
No. Z squared. We already worked it out.
Minus 2 minus 4.
Yeah. Pause it there. Alright. Now, multiply it out. Derma, what do you get when you multiply it out? Minus. Yeah. Yeah. 2ti, yeah. Yeah. Okay. Now, this, yeah one, that one, and that one. They're all real, aren't they? Then what about the next part? That one. And that one. Alright, what two equations should I get now? We're on 15, okay? Daniel? K plus t equals minus 6. And for the yellows? Minus 2k plus 2t equals? Minus 8. You don't need to put in the i's. Alright, quickest route to victory would be to do what? Multiply the green equation by? It's a minus 2k there, so what can I do to change that into a plus 2k? Huh? Oh, divide the bottom 1 by 2 is another way doing it. Yeah. Sorry, we'll do John's way there. John said, why don't we just divide the bottom equation by 2? I'm all for that. Get that. Now, 2t equals minus 10, t equals minus 5, and then k plus t is minus 6, so k k minus 5 is minus 6. Anybody get k equals minus 1?
Yeah.
It's going to be minus 6 plus 5. K equals minus 1. Who got that one right out of interest?
Yeah.
No. 1 plus I. Then the conjugate, guys. And you have to prove the answer is I. John, what do you do?
You do 1 plus I.
You multiply top and bottom by the conjugate of the denominator. So you identify the denominator, and you get the conjugate of that denominator. Okay? Now, Kirby, what do you get when you multiply that out?
1.
Yeah, loving life. Keep going.
1 I.
Yeah. Is that you or Jarvis? I squared is minus 1. Tony, it's minus 1. Alright, now. Connor, the bottom one.
1 plus I minus I.
Minus I, yeah. Too fast at me at the end. It's minus I squared, which is minus 1. Yeah, thank you, Neil. Alright, on the top we have 2i, and on the bottom 2. There we go, a really easy question here. So, Max, what's 2i divided by 2? I. Go on. Alright, we're back. Alright, question 20, anybody? Alright. Owen, what's the conjugate of, 4 over w, what's the conjugate of the denominator here?
2 plus 2I.
Nearly. The conjugate of 1 minus I?
Oh, sorry. 1 plus I.
Yep.
Yeah.
There, yeah. Alright. Now, you want the answer as a regular complex number. Did everybody see that? All this part I'm highlighting here. Also that means is you want it as a regular complex number. X and Y can be any number, positive or negative, and they can be decimals or fractions. If I change that to an n, what would be the effect of that?
Only 1.
Both of them would have to be positive whole numbers. 2 plus 3i would qualify, but 2 minus 3i would not be allowed. If I change it to z, what would that do? Both of them are allowed, but if I had an answer like this, it would not be allowed. Why?
Fraction.
Fractions are not elements of sets. Okay, that's all what that little part means. Doesn't mean much else. Basically, let's do the question, and it should work out. Okay, multiply the top, we go for Michael. 4 times I, 1, plus by I, and the bottom, Michael, 1 times 1. Yeah, 1 plus 1i, yeah. Minus 1i. Minus I by I.
Squared.
Yeah, minus I squared, which is minus 1, which is, yeah. On the bottom, the i's cancel, and you're left with 4 plus 4i divided by 2, which is, John? 2 plus 2i. All good with that? Okay. Next thing we're going to do is A and B. Yes. Now, lads, we're going to fill in some numbers here. Alright, first of all, what's 4 over W? That's what we got in the first question. 2 plus 2i is 4 over W. What's W plus 1? So get this and add on 1. What you get? 1 plus 1? 2 minus I. Alright, in question 1, we did W 4 over W. In question 1, the answer we got was 2 plus 2i. Are you with me there? Now, what I'm going to do is I'm going to highlight this part here, and I'm going to replace it with that part there. That's where I get this part here from, yeah? All I've done is replace that yellow part with that yellow part. Next thing, I'm going to highlight this blue part here. And this blue part is W plus 1. So I'm going to get my 1 minus I, which is W, and I'm going to add on 1. And that will be 2 minus I. So it's going to be minus B by, what's it, 2 minus I. So I simply replace the 2 minus I, I'll go further down here. Drag this down a little bit, no, I won't. Run out of bar space basically. Alright, it's B times 2 minus I. And then, see this part here, Cormac? The W plus 4? It means that's W. W is 1 minus I. And then you add on 4. So what's 1 plus 4? So it's 5 minus I. So it's going to be 2 times 5 minus I. So if colour code this, what I'd say is that the W plus 4 is 5 minus I. And the W plus 1 is 2 minus I. So I'm probably in your way there. Okay. You'll probably just need to have another look later on. Multiply it out, and what do you get? 2a plus, yeah, yeah, plus bi. Is it bi or b? Just a b, buddy. So it's not a bi. And then on the other side, 10 minus 2i. And then what do we get then? Use the highlight system. 2a minus 2b equals to 10. And then yellow. bi equals minus 2i. Do the colours help you or make it worse? Alright, grand. 2a minus 2b equals 10. And then we have 2a plus b equals minus 2. We could go for the Jonathan method here. What would be the Jonathan method from earlier? The opposite. Divide the equation on the left by 2. And you end up with a minus b equals 5. Which is a smart move. Add them both together. We get a 3a equals 3 and a equals 1. 1. Now, what it says next is 2a. I'm going to use this equation here, where I have 2a plus b equals minus 2. I'm going to do 2 times 1 plus b equals minus 2. 2 plus b equals minus 2. This implies that b equals minus 2 minus 2, b equals minus 4. And we're done. Alright. X times that. X times I. Minus xi. 2yi times 1. 2yi. And then 2yi times minus I is I squared minus 2y times minus 1 gives 2y equals 7 plus 5i. Alright. Now, that by that, that one, and that one, and then green. Alright. X plus 2y equals 7, yeah. What's the other one? Minus x plus 2y equals 5. And we're quite fortunate here, why? Yes. Yes, they do. 4y equals 12. Y equals 3. Then x plus 2 times 3. I'm using x plus 2y equals 7. So x plus 2 times 3 equals 7. So x plus 6 equals 1. 7x equals 1. So 1.